Good morning, students. We'll move on to the next topic, recognition of tokens. So in the previous session, we studied like what should be the components of pattern exactly. So we are using the regular expression to identify some different patterns. Okay. So using that pattern, now we need to identify what kind of token should be generated over here. Okay. See, remember one thing. So we are going to get different kinds of tokens over here. For keyword, we are getting one kind of a tokens. For relational operations, we are getting one kind of a tokens. For identifiers, we will be getting a different kind of tokens over here. So on what basis we are going to identify? Yes, this is about the keyword, and this will be the identifier, and this is what the relational operators over there. Okay, relational operator means less than, greater than, equal to, such kind. Okay, greater than or equal to, less than or equal to, not equal to. So these are all we are considering it as relational operators exactly. Okay, and sometimes we are identifying a series of strings also. Okay, so for those type of inputs or those type of statements, whatever we are having in our source program, okay, for each and every statement we need to generate the tokens over there. Okay, but on what grounds? Based on the regular expression. Okay, so here we are depending on some pattern. Remember, okay, lexem means what? A group of, or else a streams of a character. Okay, so that character we are comparing it with the pattern. Okay, if that pattern get match, okay, for that predefined tokens are available. Okay, so that will be generated. Getting over what? See, a program will be uploaded for the compilation, right? Okay, in the first phase, lexical analysis phase, we have the job of lexical analysis is what? Okay, it used to generate the tokens for the source program. Remember this. Okay, so how the token will be generated? First, we need to group some particular character as a lexem. Okay, so that lexem will be compared with some particular pattern. Okay, pattern means regular expression. Okay, so for keywords we have one pattern, for identifiers we have another pattern, for relational operators we have another pattern over there. Okay, so on what pattern the lexem is, okay, so that will be compared. So according to that pattern match, okay, we are deciding what kind of token should be generated over there. Okay, so here we have an example, explanation. We must study how to take a pattern for all needed tokens and build a piece of code that examines the input string and finds a prefix that is a lexem matching one of the patterns over there. Okay, so whatever the pattern we are available with, okay, for that which pattern, okay, your lexem is going to be matched. Okay, that we need to observe. Okay, now see here in this example we are using some regular definitions over here. Okay, statement, expressions, terms. Okay, so these are the three different example over here. So in this statement, okay, stmt we are using for statement, for expression expr we are using, and for terms, okay, we are using term, shorthands we are using. Okay, so now when it comes for if statement, see here we got one if statement. If expression, okay, if the syntax, okay, just imagine we are writing a C program. If open bracket some expression will be available, okay, then like if n is greater than 1, okay, that is what, open bracket, n is greater than 1 close bracket, okay, then later, okay, then statement will be there. If this expression matches, then below that we will be having a print statement, right? Okay, that stmt stand for a print statement exactly. Okay, so if this is what the case, see here how we are going to split this if statement. Okay, see, if is a keyword, okay, so in bracket we will be having an expression, right, greater than or equal to, okay, or less than or equal to something. Okay, n will be compared with some particular value, that expression will be available. If it match, if n value is greater than 1, okay, then some statement should be printed over here. If and then are the keywords, okay, and expression and statements, okay, these two are what? These two are, we need to identify whether it is an identifier, whether it is a relational operator, or what kind of lexem it exactly. Okay, so if is one lexem, for that one particular token will be generated. For expression another will be generated. Then this is also a keyword. Okay, we are generating a token called as a keyword itself. Okay, and statement we are having. Now we need to analyze. Okay, simply blindly we cannot do this. Okay, we need to analyze what kind of pattern we are going to get for that statement exactly. Okay, so this is what one kind of a statement, right? If statement. Second, or we are having one more here. If expression, then statement, else statement. Okay, if expression, then statement, else one more statement over there. Means if this expression satisfy, okay, if the condition satisfy, then we are printing the first statement, or else we are going for the second statement. Okay, so here there are three keywords. See here, if, then, else. Okay, see, these are the three keywords. So if I want to generate a token for this particular second line, okay, for if keyword as a token we are generating, then it is also a keyword. The token name will be keyword, okay, and for else also the token name will be keyword exactly. Okay, for expression, statement, last two statement, what should be generated? It is according to the pattern what you are going to write over there. Clear? Fine. Okay. Otherwise, epsilon we are having. Okay, if that condition does not satisfy, okay, then we are not printing, not at all printing anything over there, right? Okay, then when it comes first here in first example also, if expression then statement we are having. Okay, statement means what? Anything it may be, let it be. But when it comes for the expression, just observe here, expression means what? Term. Okay, we may be having some term. Okay, after that it will be followed by some relational operator. Okay, and again it will be followed by some term exactly. Okay, so this term, okay, what exactly this term stand for? See here, below that we have a term example. Term can be ID. Okay, ID stand for what? Identifiers. Okay, it may be a variable. Okay, remember. Okay, identifiers. Okay, means some information, some data. Okay, so ID, it may be, the term may be ID or else a number. Term may be ID or else a number. N I said, right? Okay, n greater than 1. If n greater than 1, then print, okay, some statement we are having. Okay, now in case of this, the example, just observe here. Okay, this example, term, relational operator, and again you are having term, right? Fine. So the first term, if I consider n, okay, relational operator greater than term as 1. Okay, means n greater than 1. So term means what? Identifier now, because n it is. N we are considering it as identifier. Relational operator what we are using? Greater than we are using. One more possibility of term what we have? Number we are having. Yes, n greater than 1. Okay, so this is in the format of expression exactly. Clear? Okay, so these are the what? Some pattern. Okay, it is not compulsory like, okay, same pattern we should have. Okay, any kind of pattern it may be. Okay, so these are the different pattern we are utilizing or we are using to identify, remember, to identify what kind of token should be generated. That's it. Okay, so this we call it as grammar for branching statements. Okay, so this is what the example of a grammar for branching statement exactly. Now when it comes for the grammar or regular expression or whatever we are using, okay, the terminals we have. Okay, terminals means what? Okay, they are very important thing while constructing a language. Okay, terminals of grammar exactly. Terminals of grammar. Okay, there are two varieties, non-terminals and terminals. Remember, okay, non-terminal means capital letter. Okay, and the terminals means the small letter values whatever we had from ATC. That is what? Terminals of grammar exactly. So here, okay, fine. We'll go for the explanation. If, comma, then, comma, else, comma, relational operator, comma, ID, and numbers are the names of the token. Remember, so these are the different names of the tokens we have. Okay, varieties of token. Okay, types of token. If statement, then, else, relational operator. See, if, then, else, we are categorizing it as what? Keyword. Remember this, we are categorizing it as keyword exactly. Okay, then relational operator, less than, greater than, equal to, such kind of any operator. Okay, like the right hand side is related to the left hand side. Okay, such a kind of expression we are writing. Okay, then the in between symbol what you are using, that we are considering it as what? Relational operator. Clear? Okay, then apart from this, another type will be what? Identifiers, okay, or else numbers. So these are the different name we are utilizing or we are using to represent the token over there. Okay, then pattern for these tokens are described using regular definitions over there. So here we got different regular definitions over here. Digits, number, letter, ID, if, then, else, relational operator. So these are what we call it as relational definition. Okay, they got some internal meaning over there. Okay, now we'll go through this. Digit we have. The first one is what? Digit. What does digit stand for? Okay, digit means what? A number starting from 0 and ending with 9. Okay, like 0 or 1 or till 9 exactly. Clear? Then digits we are using. Digit means what? 0 to 9, any one value. Okay, digits means what? See here, within a bracket, digit to the power of plus. What does this power of plus stand for? Okay, one or more. The occurrences of digit will be what? One or more exactly. If I want to write like 0011, okay, then this digit is not enough. Okay, what we want to go? We want to go for regular definition called as what? Digits. What is it? Digit stand for exactly? Digit to the power of plus. Plus means the occurrences of digit will be either either one or more. Okay, one or more it should be. Okay, fine. Now, don't get confused with this number. Okay, so we are representing it like, okay, example. Just if you have a paper and pen, just try to write. Okay, what I am going to dictate now. 1.7. I repeat, 1.7 e minus 4. 1.7 e minus 4. Okay, so this is what one of the example. Okay, see, it may be or it may not be. Fine, we are checking for each and every possibilities over there. Okay, if you are having a decimal point in between, okay, if you are having a normal number of 556, okay, if you are having a normal number of 556, then this first one, digits what we have, this is enough actually. Okay, but okay, see here, digits we are having, my example was 1.7 e minus 4. I think, okay, I'm right. Okay, 1.7 e minus 4. So this is what the number. Okay, one number we are having, just consider it as. Okay, so that first one we have, right? 1 point, just observe digits. Okay, 1 will be written in the place of digits, then open bracket dot digits close bracket question mark we have. This question mark is for this particular bracket exactly. Opening bracket and close bracket, between that whatever we have dot digits, for that we have a question mark. What is the meaning of question mark? 0 or more means it may occur or it may not occur. Okay, if it is occurring, yes, one time it will occur, okay, or else 0 time it will be. Means another example was 546. Okay, if I want to mention a number called a 546 where we have a decimal point, we don't have a decimal point. Okay, then this dot digit within a bracket later question mark will vanish. Okay, but when it comes for 1.7, yes, here dot digit will occur over there. 1.7, see, 1 will be represented by digits, 0.7 will be represented by this bracket exactly. Inside that dot digits we are having. How many times it used to appear? Okay, it can appear only 1 or 0 time. 0 or 1 exactly. Then later one more bracket we have, e we are having. Just observe, e we are having. Right? Okay. E means what? Exponent value. Okay. Like e we are using, right? Sometimes we are going to write e value over here. It consists of some particular value over there. Then after e, sometimes, okay, we may be having a sign over there like plus or minus. Okay. Plus or minus. Okay. So this plus or minus is also optional. See, okay. See, for this complete e, open bracket, plus or minus, close bracket, question mark, digits, closing bracket, question mark. This whole bracket what we have, okay, this becomes optional. See, this one becomes optional. Why? Because at last you are having question mark. Okay, and inside that also we have one more question mark for a bracket, okay, for which indicates plus and minus, right? Okay, like after e, okay, if it is possible, we can use plus or minus over here, otherwise you can neglect, no problem. Okay, such kind of numbers are available. Okay, if you Google, okay, we can get a different number, different example for this particular number exactly. Okay, e followed by plus or minus, or else we can neglect this plus or minus, later it will be followed by digits exactly. Okay, and this is also optional. See, when I want to provide an input, or if I want to mention a number in my program like 1.7 e minus 4, then this pattern match, is it right? Okay, but when it comes for 546, okay, then after this bracket, after digits, we have a dot digits bracket, right? Okay, this is unnecessary exactly. Okay, but still both the numbers should be considered as a number itself. Remember, both are number itself. For that we are using this kind of pattern. Okay, fine. See here, just observe. Okay, when we get 0 to 9 only any one value, then we are representing it as what? Digit exactly. When we are getting a series of number, we are considering it as a digits. When we are getting this pattern like 546, yes, it is number considered as a number. Okay, if you are getting like 1.7 e minus 4, okay, that also should be considered as a number exactly. Okay, then later when it comes for letters a to z, small a to z, okay, so if we have this kind of a pattern, then we are considering it as a letter. Okay, now just observe, id we are using. Okay, you may be having confusion like for what purpose we are using the id over. The id means what? Identifier. Okay, see here, letter. What do you mean by letter? See here, what do you mean by letter? A to z over there. right? Okay, now identifiers are example n, yes, it is also one of the identifier we can use, or else the position, one of the identifier. Okay, then according to my example, okay, in this model we took a example like position is equal to initial plus rate into 60 exactly. So in that position, yes, it is also an identifier, initial, yes, it is also rate, and it is also clear. Okay, letters, whatever the letters we are having, followed by, see here, letters are followed by, we have an option 0 or more occurrences, because star we are having 0 or more. Don't get confused. Question mark is for 0 or 1. Plus is for what? 1 or more. Star is for what? 0 or more exactly. Okay, so letters followed by letters, or letter followed by digit exactly, like n9, n5, okay, n6. Okay, so these are the what? Some kind of identifier we may use in our program. Clear? Okay, it is not compulsory like we need to go for using letters, after that digits only. No. Okay, it is free, programmer is free to use letters itself, or else if we want, he can go for using letter, later digits over there. So that pattern, okay, or else this pattern we are considering it as what? Identifiers, ID. Then whenever you have if then it will be considered as if itself. Then whenever we have then it will be considered as then itself. Else means else itself. So these are the keywords. Remember, these are the keywords exactly. Then relational operators, I told you, right? Relational operator, n greater than 1. That was my example. If n greater than 1. Okay, so greater than symbol, okay, less than symbol, greater than or equal to, less than or equal to, then not equal to. Okay, so these are the what? Different symbols we may use in our statements over there. Okay, so these are the few patterns. Right hand side are the different pattern. Okay, for this particular pattern, what kind of regular definition we need to write or we need to identify? Okay, that is what the left hand side it is. If this pattern identified, okay, then the left hand side, whatever the name we are having, that will be considered as a token exactly. Remember. Okay, so here token, their pattern and attribute value is mentioned. There are 3 columns. Okay, so the first column, don't get confused, first column lexems we have, second column token name we have, and attribute value. Remember, attribute value, why we are mentioning? Okay, if we are using multiple number of times, okay, in single line, in single statement, the same value we are utilizing or we are using more than once, okay, then we need to identify which one will be used first, which one will be used next. For that we are using the attribute values over there. Okay, so like that, okay, fine, we'll see that. Lexem we are having, if statement we have, then statement we have, else we are having. Okay, now in case of if, what will be the token name we are generating? Just observe, if we say lexem means programmer is writing if statement. Okay, whenever we find a if in our program, the token we are generating is what? If itself. What is the attribute value? We are not generating any attribute value because it is a keyword. Remember, it is keyword exactly. Okay, so when we're discussing next topic, you will get to know, okay, the keyword should be reserved in the symbol table. Remember, initially we need to install the keyword. Okay, like we may be having, okay, statement like if he is in Bangalore, okay, or if he is in Mysore. Okay, so there also we have a statement called as a if. Okay, but it should not be compared with, or it should not be conflicted with the keyword exactly. Okay, that is a statement, but it is a keyword exactly. Remember this. For that purpose, we are not mentioning any kind of attribute value over here. Then yes, exactly, it is also a keyword. Token name will be then itself, else itself. Okay, then when it comes for the identifier, any identifier like n, or else stock, okay, or else a market, or else anything, position, initial, or else a rate. So these are the different identifiers we are having. Such kind of identifiers like letter followed by letter followed by digit, if it is there, okay, then it should be called as ID exactly. Okay, and meanwhile, what should be the attribute value? Okay, pointer to table entry, where exactly that will be storing in the symbol table. That pointer location should be identified over here in the attribute value over there. Then when it comes for any numbers, okay, okay, it should be identified as number itself. Okay, pattern, sorry, pointer to table entry. Okay, this also, where exactly we are going to store that particular number, that should be mentioned. Okay, for that we are using the attribute value over there. Then when it comes for relation operator, just observe, less than we have less than or equal to, not equal to. Okay, then greater than or equal to. Okay, so for all these symbols we are using a token name called as what? Relational operator, RELOP. Okay, whenever we find this kind of symbol, okay, your token we are generating is what? Relational operator. Clear? Next, okay, then what will be the attribute value? The meaning of this particular symbol. Remember, the meaning of this particular symbol, okay, should be identified. LT, less than. less than or equal to, then equal to, then not equal to, then greater than or equal to, sorry, greater than, only greater than, at last greater than or equal to. Okay, now, so this is what the identification, how we can do for the token based on the pattern and all. Okay, now, so this is what the manual procedure. Okay, we can identify, we can take some example, we can compare. Okay, because we are having a knowledge about these kind of pattern recognition and also we can do this. Okay, but how this system or how your compiler, okay, is going to perform these kind of aspects. Okay, so what we need to do, we need to go for a transition diagram. Okay, so in the previous semester in ATC we were designing a DFA, NFA, epsilon NFA, okay, different kinds of grammar and all, okay, for identifying what the patterns. Remember, okay, whenever such kind of pattern occurs, okay, finally it will end up with a final state. Okay, whenever you are missing the pattern, okay, then it should be end up with a dead state, or it should not end up with the final state. So the pattern which is ending with the final state, we call it as accepted. Okay, otherwise it will be rejected. Okay, like a to the power of n, b to the power of m. Okay, for that we are designing a DFA, we can design a NFA, we can design a epsilon NFA. Okay, we can generate the output over there. Okay, so here also we are identifying some patterns, okay, to decide which token we need to generate. Clear? So here also we need to go for transition diagram. Okay, we need to use a DFA or NFA. Okay, so that your lexical analyzer should recognize what kind of token can be generated for the lexem. Okay, as usual, okay, it consists of states. Okay, so it will be having a start state and final state. Okay, so start state will be having an arrow mark, okay, from nowhere. Okay, like it will be labeled as a start itself. Okay, final state will be having a double circle. Fine, so that indicates what, that is the final state. Okay, the end of the transition exactly. Okay, then edges will be labeled. Okay, what kind of action should be taken between state 1 to state 2, state 2 to state 3. Okay, like that label should be identified over there. Okay, so these are the few aspects. Fine, but here you can read these things. Okay, like how we can draw the transition diagram and all we have. Fine, but here just observe the second point. Okay, it is necessary to retract the forward pointer one position. Okay, then we shall additionally place a star near that accepting state. Okay, so this is what, like for few cases, I will explain it later. For few cases, okay, the final state will be having a power of star exactly. Okay, for what purpose? We need to retrack. Okay, remember, whenever we are uploading the statement for the buffer, we are using two pointers, right? One lexem pointer, okay, another one forward pointer exactly. Lexem pointer is pointing for current lexem exactly. Remember, okay, for what purpose you are going to generate the token, or for what particular pattern you are generating, you are trying to generate the token. Okay, for that it will be pointing for. Okay, then your forward pointer will be pointing for the next lexem. Clear? It will be pointing for next lexem exactly. Okay, so now example, I am just taking an example. Okay, consider that lexem is occupying total 3 different locations of the buffer. Consider one lexem we have, okay, that is occupying 3 different location of a buffer exactly. Then your forward pointer will be pointing for 4th location. Okay, it indicates that from there exactly it will start the next lexem exactly. So what we need to do, if we want to get exact length of lexem, you need to bring that forward pointer one step back. Clear? Okay, so that you can get the exact length of that particular current lexem exactly. Clear? For that purpose we are using star over here. Okay, fine. Rest of all things you are very familiar, okay, from ATC. Then we'll go for transition diagram for relational operators. Okay, means whenever you find any relational operators, then what kind of transition diagram we need to write for the compiler. Okay, so that it can identify the pattern, okay, and it should indicate that whether it should be accepted or whether it should be rejected. Remember, if I write greater than semicolon, what exactly it means? We don't have any meaning over there, right? Okay, greater than, after that blank also, okay, fine, no problem. Okay, if you are having greater than, after that one blank, later one value if you are having, then no problem. It is what the proper syntax over there, it should be accepted. But greater than semicolon, you don't mean exactly, right? Okay, so such kind of pattern should be considered as what? Error exactly. Okay, for identifying the error or to check whether it is in a proper format or what, okay, what we need to do, we need to go for a transition diagram of relational operator. Now see here, we are having different states, I think 0 to 8, so different states we are having. Okay, we'll begin with 0. So first, less than you have, just observe, less than you are having, right? Okay, after less than, what are the possibilities of less than? After that, what it may follow? See here, three things it may follow over there. Less than, later blank it may be, after that it may be followed by any value over there. N less than 1, right? See here, n space less than space 1 exactly, right? Okay, so in that case, observe it carefully, only less than I'm using. In that case, how it will be traveling, right? 0 to 1. See, if you are encountering less than symbol 0 to 1 transition, then what you have? You don't have any other symbols like equal to or greater than. Okay, so what it will do? It will come from 1 to 4 exactly. 1 to 4 exactly. So here, okay, other we are considering it as. Okay, after, just observe, after the less than symbol we don't have anything, so we are considering it as other exactly. Then it will be coming for 4. 4 will be accepted. Okay, means 4 is a state of final state. It is a valid syntax of occurrences of relational operator. Then another possibility, second, just observe, less than, after that if I mention equal to, less than or equal to, okay, that condition, then it will be traveling from 0 to 1, 1 to 2, yes, it is accepted. It is accepted exactly. Okay, now relational, what it will be returning? It will be returning relational operator, comma, what is the attribute we are returning over there? LE we are returning, right? Return, what it is going to return? Relational operator, comma, LE. What is it? RELOP? It is a token. Remember, it is a token, comma, LE we are having. So this is what the syntax of token, token name, comma, attribute value. Okay, what is the attribute stand for? Into, see here, less than or equal to, less than or equal to. When it comes for, see here, less than, greater than, we are considering it as not equal to. Okay, so that will be considered as not equal to. But when it comes for only less than, see here, relational operator, comma, LT we are using. Then sometimes we may be having only equal to, right? N equal to 1, then 0 to 5 equals, it is relational operator, it is, what is the attribute value? Equal. So that will be the return value. Okay, so for greater than, equal to, only greater than, okay, we are having this kind of return value over there. Okay, so this is what the transition diagram what we got for handling relational operator over there. Then when it comes for creating create separate transition diagram for each keywords. Okay, so here we are using a keyword called as then. The spelling of then will be what? THEN. So we are beginning at state 0, which is the start state. 0 to 1, T it will be, 1 to 2, H it will be, 2 to 3, E it will be, 3 to 4, N it will be. Okay, then next to that, see here, non-letter. See here, then is if it is followed by a non-letter or digit, okay, we need to check. Okay, then after that, non-letter or digit, okay, if it is followed or what, we need to check. If it is the case, then it will be accepted. Non-letter or digit means what? Any character, okay, that cannot be the continuation of an identifier. Any character, I repeat, any character that cannot be the continuation of an identifier. See here, then is a keyword, right? If I write then full stop, whether it should be considered as a keyword, then semicolon, if I write it as a code, okay, then whether it will be considered as a keyword? No. See here, then is a keyword, it should not be followed by anything else. Okay, that's why we are naming it as what? State number 4 to state number 5, non-letter or digit. Okay, like non-letter or digit, not non-let or digit. It should not be followed by anything. Okay, space, yes, possible. Okay, because see here, after then, okay, if statement, if n is greater than 1, okay, then print statement will be there. Okay, so next to then statement or next to any keyword statement, space if it is there, yes, it is acceptable. But if it is followed by any letter or if it is followed by any digit, okay, then it is not at all possible. Okay, that should be avoided. Okay, so non-let or digit stand for it should not be followed by any kind of identifiers. Okay, so this is not only for the then statement, it is same for the if, it is same for each and every keywords whatever we are using in our programming. Clear? Okay, if this pattern satisfies here, THEN, it is not followed by any other letter, any other digit. Okay, if it is followed by a space, then it will be accepted. See here, 5 we are having, right? 5 is a final state. Okay, so it will be considered as a keyword. Then, so this is what the example of number. Okay, as I explained, like 1.7 1.7 e minus 4, right? Okay, so based on that example I can explain this. See, start state we are having initially 0 we have, so the first value it was 1 exactly. Yes, it is a digit, right? It is a digit, right? 1. Yes, observe it carefully, I'm not mentioning it as digits, it's a digit, just a digit. We are checking for each and every value. Okay, now okay, digit we have one value we are having. What is the value of that? 1 exactly. Okay, so digit, then it will be changing the state from 0 to 1. Now if it is followed by any other number, okay, like 1, my example is 1.7. okay, let it be. If it is like 117 1.7, then 2 number it will be available, right? So it will be in a loop. Okay, in state number 1 it will be in a loop exactly. Any number before the decimal point, it will be staying in state 1 itself. Okay, next, if it is finding e after that, okay, or else, okay, fine, don't get confused. Okay, we'll go for our example itself first, then we will go for the e. Okay, next, after the digit, okay, 1.7 we are having, right? 1, okay, it will come for state number 1. Okay, what we have in the next point we are having, so state will be transferred from 1 to 2 exactly, dot we are having. Then later, just observe it carefully, we are in the state 2 exactly. Now what will be the next value? My example is 1.7. okay, 1.7, 1 over point over 7. So now you are changing the state from 2 to 3 exactly. Okay, so if you are having more than one value, okay, after 7 if you are having still some value, it will be in state 3 itself. Clear? Okay, then if it is followed by e, just observe, if it is followed by e, okay, then directly you are changing the state from 3 to 4 exactly. Next, plus or minus, my example was 1.7 e exactly. Okay, my 1.7 e minus 4. Okay, if I find minus, 4 to 5 it will change. If I find plus also, 4 to 5 it will change. Clear? Okay, fine. And you can observe, instead of this plus and plus or minus, if you are followed by any digit, e is followed by any digit, means 4 to direct 6 it will go. Clear? And it will be reaching the final state over there. Like this, the transition diagram for numbers we are going to mention. Clear? It is not compulsory like each and every number should be following the same particular pattern. Okay, like we are designing this particular DFA for what reason? We are designing this only for accepting each and every possibilities of number exactly. Clear? Okay, so this is what the transition diagram for white space exactly. Okay, delim we are using. Delim is nothing but white spaces, new line and blanks. Okay, if we are having any these kind of aspects, okay, then that is what the pattern, okay, we are identifying. Fine. For identifying the white space and new line and blank lines. Okay, so we are using another transition diagram. Okay, 0 to 1. Okay, again, how many number of spaces you may be having? Like if I write we are from ATM, space full stop. Okay, so there are many number of white spaces available over there. So we are going to check like 1 white space or 2, 3, 4, 5. Okay, like that. So we are having a loop for delim in state number 1. After that, if it is followed, like if it is in a proper format, okay, then it will be accepted by state number 2 exactly. Clear? Okay. Now this is very important. Okay, recognition of reserved words and identifiers. Okay, now we have a conflict. Okay, see, we cannot restrict the user, like you are not supposed to use a word called as if. Okay, if I want to use, then it should be only for statements, okay, or else a condition, if condition. Okay, other than that, you're not at all allowed. Okay, such kind of restriction we cannot pose for the programmers, right? Okay, he may be using a if condition, he may not be using the if condition, but our compiler should be in a position that it should differentiate which is what the word reserved word, that is nothing but the keywords, and which are the identifiers. Okay, see, for both reserved word and identifier, we are using the same transition diagram over here. Okay, state 0, letters you will be having, okay, letter followed by letter, okay, or letter followed by digit. Okay, example if statement, observe it carefully. Example if statement, yes, what are the letters which will be having? I we have and F we are having. So when I find I, 0 to 1 transition it will be. When I find F, 1 to 1 itself. Okay, it is followed by space, so it will reaching the state number 2 exactly. Accepted. Okay, then later, other than if statement, if I want to check for identifier called as a position, okay, then spelling of position, okay, will be checked. Okay, so continuously it will be in a loop number 1 itself. Okay, then later it will be followed by a space, so it will be accepting for, or it will be reaching for state number 2. Finally it will be accepted. But how to differentiate? Yes, this is what the keyword, this is what the normal identifiers. Okay, for that, see here we are using two different functions over here, get token and install id. Okay, here we have a complete explanation, okay, how they are going to work. Okay, but instead of explaining that, I will just explain the logic over here. See, whenever we load the program for the compilation, remember one thing, okay, whatever the keyword, okay, if it is a C program, what all the keywords, possible keywords we are going to get, okay, that should be updated priorly inside the symbol table. Observe it carefully. When we load our program, what all the keywords we are having, that should be updated in your symbol table. Whenever we find a keyword with respect to that, okay, based on a pattern, there will be a predefined tokens available. Did you identify it? Okay, if we statement we had, what is the token we generated? IF itself. Then we had, what is this token we generated? Then itself. Sorry, wait a second. Okay, so what was this like token we are generating, like what keyword we have? Okay, same kind of token name we are generating over there. If it is an identifier, then only we are generating it id, like a token called as a id over there. In case of number itself. Okay, now your compiler must differentiate which is id and which is keyword exactly. Remember, okay, for that we are using two different functions, get token and install id over there. Okay, see, whenever we load our program, whatever the keywords we are using, okay, that should be updated in your symbol table. Okay, for that next column, like in just for your understanding sake, first column if you are having a keyword name, okay, next column if you are having a token name. Okay, so that will be available in your symbol table. Okay, just imagine, okay, we'll be having this kind of pattern inside the symbol table. Then whenever we get any identifier, any particular pattern, okay, what we do, we are sending that information to the symbol table for the reference. Okay, for the reference. Okay, like whether that particular identifier or whether that particular keyword is already present in your symbol table or what. In symbol table, what is present now? Only keywords are present. We don't have an identifier. Only keyword is present. Okay. Now, if you are getting a identifier, any identifier, okay, so what we do, we consult the symbol table whether such kind of pattern is available in the symbol table or what. Okay, but that pattern is not available because only keyword patterns are available. Identifier patterns are not at all available. Okay, then example, okay, in line number 5 we have a if statement, in line number 10 again we have a if statement. Yes, when I find in line number 5 if statement, okay, what is the pattern? IF, so that will be communicated to the symbol table. Okay, but inside the symbol table, what is the entry we have? Yes, for if condition or if statement, we have an entry over there, we have a predefined token available over there. So what will be the return? Lexem found. Remember, the return will be lexem found. If what you are trying to identify the token, if it is already available, remember, if it is already available in the symbol table, we will be having a reply message from your symbol table that lexem found. Okay, then when we get this lexem found, we are as a reply to this, okay, we are activating a function called as get token. Activating a function called as get token exactly. Okay, when you activate this, you are going to receive what kind of token we already have in the symbol table. Clear? Otherwise, if it is not available, okay, we are going to check for the pattern what exactly the identifier is having. Okay, so according to that pattern, whether it is an identifier or keyword, it will be identified. Okay, and the return message will be what? ID, or else a particular keyword token will be the return value over there. Clear? Okay, we have a conflict between these two, like reserved words and identifiers over there. How we can overcome this problem? Whatever the keywords we are using, upload it for the symbol table in the prior session itself. Okay, so for them we'll be having a predefined tokens available. So while compilation, whenever you get any word, okay, it may be an identifier, it may be a keyword, anything it may be. Okay, just go and refer the symbol table. That's it. Okay, if you have already entry, okay, for that particular syntax or for that particular pattern, it will return the token, okay, which is already available. If it is not, just go through that identifier pattern, just identify whether it is a number or whether it is a ID. Okay, then according to that, send the token over there. Okay, so this is how we recognize the tokens exactly.